Hello everyone, this is TheBridge4Math coming right at you with another great math video. Today we have a tough question on systems of equations. So if you're in an area where you have multiple equations and you need to solve for several unknowns, this example is for you. So let's read the question. The question says find the quadratic function y equals ax squared plus bx plus c whose graph passes through these points. So I want to talk to you a little about that. Do you remember that a graph actually represents the solution to an equation? Every possible solution. And if we're given three different ordered pairs, pieces of information, we can actually try to calculate the unknown a, b, and c. So right now, do you agree this is what I call general form? A general quadratic formula, ax squared plus bx plus c. Our goal is to solve for the a, b, and c to make the exact function that represents the graph that goes through these 3 points. So remember with functions, x input, y output, if you look at this, a, b, and c are just going to be numbers. They're going to be coefficients of this quadratic equation. Now, for the first ordered pair, 0, negative 5, you're going to discover something beautiful about x being 0. But you plug in 0 wherever you see an x, and negative 5 is your y value, so you plug in negative 5 for y. So all we have to do this is we have to formulate a system of equations. What do I mean by system? System means that when you come up with the equations, like in this case, this a and this a and this a are the same a, or x, whatever variable they're choosing to use. But I'm plugging in x is 0 into the general format for a quadratic equation. See what happens here. 0 squared goes to 0. 0 times a cancels out here. Let's keep going. B times 0 cancels out again. Don't you love it when things cancel out? You end up getting negative 5 is equal to c. Whoo! Fast find. Boom! Immediately you know that the c on this quadratic function is negative 5. I love it. That's going to simplify our life greatly. So instead of having 3 unknowns and 3 equations, we really come down to 2 unknowns and 2 equations. So let's get those 2 equations. Let's take the other ordered pair. X is negative 2, y is the negative 7. Plug it into the general quadratic equation. You have negative 7, the y value, equals a times negative 2 squared, b times negative 2 plus c. But we know what c is, negative 5. Negative 2 squared is positive 4. So we create this equation. Now you remember I try to teach you good habits? I like this, remember this, letters on the left. So essentially I switched this side to the other side to bring the letters to the left. That's the commutative property that allows you to move things around. We also want to get letters alone. So I'm going to take this negative 5, we're going to get to the other side. How do we do that? Well, you can add 5 to both sides. What you do to the right, you do to the left. We come up with this beautiful simplified equation, 4 times a minus 2b equals negative 2. But let's remind you, what the heck am I looking for again? This a and b will be the coefficients for the quadratic function that we're trying to find. Let's look at the third ordered pair. So you notice we started with 3 unknowns, which means we needed 3 equations or 3 pieces of information. We're going to plug in x is 1. Oh, I love the math when they give you nice things, nice professor. Put in 1 squared, 1 here. All of a sudden you have 14 equals a plus b plus c, but we know c is negative 5. Get the letters on the left again. You end up getting a plus b equals 19. So now we've created the equations, the system of equations with the given information. In some sense, just knowing what to do first was really important. So we are solving the system of equations. I'm going to give you a hint. When you have variables like this with no coefficient, no number in front, I recommend using the substitution method. So I'm going to solve for a with this particular equation. You get a equals 19 minus b. I'm going to take this and I'm going to plug it into the other equation. What do I mean? Why not? Why not the first equation? You'll find out it's not smart to plug it back into where you started. Go to the other equation. Why am I doing that? What does the substitution method do? It essentially allows you to make one equation one unknown. So look at this. You started with 4 times a. Well, now it's a is 19 minus b. So now it's 4 times 19 minus b. I plugged it in or substituted it in. You still have the minus 2b equals negative 2. But now I have one equation, one unknown. Do a little math, distribute, multiply this through. Get the like terms. You add like terms, you get negative 6b. You do your math, keep pushing through. You get b alone. You get b equals 13. Yes. Now once you have b equals 13, is there a particular equation that would be really easy to use to get a? Absolutely. It's the one you used for substitution. A equals 19 minus b. 19 minus b, where b is 13, so a is 6. Holy moly, you got a, b, and c. You got all those unknowns. Putting them together, here is that beautiful quadratic function that went through those 3 data points. The question didn't ask it, but notice it's a positive number 6, so this problem opens up with a smile, and it's going fast. It's booming. See how narrow that is? It shoots up really high. When you got x squared, it makes the number big. Vertex down here that you didn't have to calculate. But I hope that helps you. I know you're drinking from a fire hose. That's a lot of information. But if you look back, stop the video at places, you can do it. This is the Bridge for Math coming at you. Have a great day.